thing, so you should probably move that.
Well, I think
but it is working. Okay. So first thing, if anyone is already watching, sorry for the delay. We had some technical difficulties. Second thing, do we have sound working? Let me check that real quick. Yeah, I can hear myself on the stream, so that's fine. I'm going to announce that the stream just started, and after this, Paulo will play we have sound. Okay, Alien, we have just one viewer confirming that this is working.
One viewer,
so that's good.
One
that's better than 0 viewers. So, hey PS, hey Paulo. Okay, so this is the deal. We are streaming from Paulo's PC because he didn't have time to send the video to me. The video is still rendering, but it's already playable on VLC. So
always on the limit. Always on the limit.
Works, ship it. So we're streaming from Paulo's PC, and he's gonna Alt-Tab into VLC and hopefully make OBS play VLC, and we'll watch the seminar from there. And afterwards, we'll come back to chat on this. So welcome everyone. Paulo Falcão, thank you very much for presenting to us a little bit more about Material Maker. I'm looking forward to learning a bit more about it. You showed me Material Maker before, but I think it's going to be interesting. So hope you guys enjoy, and see you in about the seminar is about 2 hours. You said, Paulo, so it's
it's 2
hours, a little long,
and it starts to get interesting about at middle. So until middle, it's only 2D stuff and working with that and programming.
Okay. Paulo, if you can check the chat somehow, try to do that. If it fucks up your stream, maybe do it on the phone. But yeah, I think people will be asking questions at some point. So feel free to either talk on the chat about it, or I'll note them down for afterwards. Anyways, let's get started because it's a long seminar. So please, Paulo, take it away. Switch the screen and make sure it's playing properly.
Okay, you have to help me. How do I switch? I resize the image.
Alt-Tab into OBS, hide this window, the Hangouts window, and display the VLC window.
Alt-Tab? No, Alt-Tab only changes the...
Go to OBS.
I'm on OBS.
On OBS, on the scene, the different ones, you can hide the Hangouts video call, and you can display the VLC.
The scene, I only have one scene.
On the screen next to it, on the other box.
On the sources?
Yes.
VLC. I can also resize, no, the screen, because I think, no.
As long as you can hide this window and show the other one, you can do whatever you want.
Try so VLC.
It's easier to click the little I to hide this window.
Okay, I understand now. Oh, I think now I can play. I think I will play now.
Hello,
okay,
my name is Paulo Falcão, and this is a seminar about doing Raymarching in Material Maker.
I've been interested in computer graphics since I had my first PC, and I started watching demos around 92, 93. Demos were amazing. I really loved demos. I started around that time doing some graphic programming, doing demos in effect, and some 3D programming. Around 2000, 2001, I became interested in doing ray tracing.
You should mute yourself, Paulo, to avoid echo.
This knowledge would be very useful for my computer graphics hobbies a few years later. In 2001, I also started to work. I didn't get time to dedicate myself so much to computer graphics. My job is server-side programming. It has nothing to do with computer graphics. I just do computer graphics for fun. In 2008, IQ, Inigo, Viles, a demo scene coder, made an amazing procedural image using just 4 kilobytes of code. That's only 4096 bytes. With that release, there was a text file where in one section you could read, "The real deal. This is some CPU Raymarching on a big 3D scalar field. No rasterization nor primitive intersections are used. There is a big map function that tells the distance to the closest surface. at any 3D point in space. You can evaluate the function to guess how much you can safely advance before eventually hitting any surface, and so take the step. I call this rendering with distance field. I wonder what is the official technical name for it. After reading this, I realized how Raymarching was done, and it was revolutionary for me, especially because although this image was done using the CPU, GPUs could already run pixel shaders, and it was possible to run this algorithm in a single pixel shader, running 100 times faster than on the CPU. I thank IQ for opening a new world for me. Suddenly, I was able to do amazing things with just a few lines of code. Truly amazing. At that time, I used a program called RenderMonkey to make Raymarching. I made hundreds of experiments. I was amazed. Around 2010, browsers were able to run shaders using WebGL. Sometime later, GLSL Sandbox by Mr. Doe was born. It was the first website where you could write shaders in the browser and share them. Lots of people started to do shaders and sharing them, and learning from the work other people have done. After some time, IQ released Shader Toy, like we know it today, an amazing place to share shaders. Lots of very smart people start doing amazing stuff there, and the rest is history. And you can ask, what all this has to do with Material Maker? Well, I loved shaders and node-based programs, and around 2015 I was planning to do a web application that used nodes to make shaders, in a way that was possible to do Raymarching using nodes. Coders would contribute with new nodes, and artists could use the nodes to create art. The interface was going to be inspired by VRXoid, a demo scene tool for making procedural demos using nodes in the form of stacked operations. But kids, work, I never had time to continue the project. From time to time, I would search the web looking for node-based programs like the one I was going to make. Early this year, in one of my searches, I found a program called Material Maker, where you could use nodes to generate shaders. It was very simple to customize the nodes code and create new one, and it was very flexible, so it was very similar to what I wanted to do. I started to talk with the developer Rodzilla about my original idea and how close Material Maker was to what I wanted to do. I wanted Material Maker to be used not just for materials and textures, but for everything, everything maker, where people could also share nodes and create a great ecosystem. We still don't have everything maker with that share functionality, but Material Maker, as is amazing, you will see. People who like procedural stuff, coding, and a node-based approach will love Material Maker. Well, at least I do. I have to thank Rodzilla for the support. He even helped me before this presentation, adding new functionality needed for it. Thank you very much, Rodzilla. So, Material Maker is an open source tool based on the open source Godot game engine. Material Maker can be used to create textures procedurally using a graph of GLSL nodes. This new texture is a resolution-independent pixel shader composed by the tool using the GLSL code from the nodes that the graph used. The pixel shader can be copied to Shader Toy and it runs. You can also have steps that render the texture to an image, and you can also apply transformation to images using nodes. Material Maker is very flexible, and it's possible to do much more than just 2D textures. I use it for Raymarching. So, we will start by downloading Material Maker. There are several options to download Material Maker. This is the official one. Okay. But here it's the latest version is 0.92, and we need some additional features, so we will not use this version. But a few days, or when the developer Rodzilla released a new version, the 0.93 will have all the functionality that you need for this seminar.
So we will use the GitHub latest release. As I said, this is an open source program made with Godot. You have to download this dev desktop builds. By the way, you also need to be registered on Git to download this build, okay? I think these kind of builds are only available to registered users. You don't need to be affiliated with the project or anything, but you need to be registered on Git to download. And now you have to, this is a zip file, you can just unzip the file wherever you like. We also need for this seminar my additional notes. So, but I had a last minute problem at my website, which is back to the pixel. I couldn't update my website, so it's still like this, but in the future, in the near future, I hope it will look like, and it will have this new item, which is just a very simple web page. And here you have a zip file. Just download the zip file, and you can put the zip file wherever you like, as long as you know where the files are. Okay, you have to unzip it, and inside there are my custom nodes. So this is Material Maker. Material Maker is a node-based program where you can put nodes in this space. Nodes are in this tree. You can also add nodes using the right mouse button and saying the name of the node. Okay. You can also drag here the output and release the button, and we will show the nodes that are compatible with this output. Okay, but let's start with this node. So this is a node that you cannot delete. This is Material Maker, so it was originally made to do these materials that can be exported to Unity and Unreal, and of course to Godot. If I just start dragging something, you will see what will happen. You can't see anything because, okay, after, if I press here, okay, you'll see a 3D model with this, but every node can also do this. Every node has a preview, and the preview it's also GLSL. It's also GLSL code. Then it's already made, but you can even modify it. So to show, just press the output. So nodes can have inputs and outputs. For example, this is a star. You can drag to change the values. So let's start making a simple node, simple 2D node. Let's use this star. Show the output. Add a circle. Show the output, and now you can combine them with blend, for example. Okay, and it's combining the two. So every output you can also export to shader toy, and let me show how you can do that. You add a debug node, show shader, and this shader you just have to copy paste it to shader toy, and it works. And do a new shader, paste it here, runs, and here you see. So back to Material Maker. Let me see other things that I can show to you. You can also, so nodes have different output types. This in gray, it's a value. These greens are images, and you can also have a sign distance functions, which are actually like this, because this is a float and it is also float, but it has a different type of visualization. This is a representation of a two-dimensional sign distance function. A sign distance function represents the distance to the surface of the object. So in 2D, this white is 0, represents 0, and here you have negative values, and here you have positive values. And you can also combine these functions. You actually use the Alt key to have a more precise value modification. Another interesting thing, some of the values you can directly use here, which is also very, very useful. And you can now join. This is a Boolean operation. Let's just delete this. Okay. You can see what is happening here. What is happening is joining the two shapes. You can do subtractions, for example. You can do other kind of functions. Another interesting thing is to create or to modify an existing node. So, for example, this node, you can press Ctrl W, or go to make selected nodes editable. And you press here, and now you can edit the node. Let's start by doing another one. Custom shader. By default is completely empty. You press Ctrl W to edit it. And now you have parameters and the inputs. And you have the outputs. So I want to just make a circle. Okay, it's an operation that already exists, but it's just for showing you. Let's call it circle. And the circle have a size. Okay, this is the minimum value and the maximum value. This is the step between how much you want to change between the two. Let's add some precision here and the default value. This control is the visual controls that you can see here. Okay, if you do apply, you will see now you have a slider there. Okay, this node will have no inputs. Okay, as an output, you will generate a grayscale image. You also have these tabs here where you can add the code, but if it's really simple, you can just add the code here. So let's start by programming the node, which is, you will use the length, and this is very important, you use the $UV. The $UV has the input, has the coordinates where you are. So we are doing a pixel shader, right? So for every pixel in your shader, you have to know where you are, the X coordinate and the Y coordinate. The UV have that values. If you do UV.X, you have the X. You do UV.Y, you have the Y, and so forth. Here we will know the length to the center, and we will remove the size. So you access the variables using again the dollar, in this case size. So by the way, here this is the name of the variable, and so I can call it, for example, size lowercase, and here is the name that will be displayed, and you can even add a description. This is the parameter type. There are lots of this kind of types. Apply. Okay. Doesn't show anything. Let me see why. So length UV. Oh, here is size lowercase. Okay, so it works. So for debugging, it's not very convenient. If you want to debug, you have to use the debug node, or we have put here the debug. You will show the shader here. You'll copy paste to the shader toy, for example, and in shader toy you will try to figure out the error. So it's not very user friendly, but you have this workaround. Another way is to compile the project in Godot, and that way you will have a console where you can see the errors. Okay. So you can see it here that the value is changing. This visualization starts here at 0, 0. That's why it's here. So for this visualization to be correct, we have to change this value. Exactly. And we probably want the inverse of this, so let's use 1.0 minus this. Yeah. You can also use, for example, do a hard edge. So let's see if this is more than 0. We will display a color. Let's call it color A. If it's not, we will color B. Okay. So, but we are not outputting a color, but we can output a color, like here. Now it's a vec3. Let's try to see if it works. I also have to add parameters, the parameters that I just created. Color A, color A, color, okay, white, can be white, this is the default value. Color B, color B, color, and it will be black. So inside white, outside black. Let's see inside if it's the opposite. So, let's try if it works. Well, no. So what we can do to check what is the error in this is to again copy the code to shader toy. Let's add a debug node and show shader, copy. Now you won't see, but let me compile. Oh, dimension mismatch. I know. It's because the color has 4 attributes. It also has alpha, and this color only have 3 attributes. So actually the output color only has 3. So this is a float. This is a vector 3. This is a vector 4, a vector 2, a vector 3. This is a vector 2 also, and this is a vector 3 as output. Okay, they are two the same, but the input is different. So these are types. For each type you have an input and an output. So for grayscale, for example, you have a float output, and the input is vector 2 UV. For the color, you also have the UV to the input, the coordinates, but you output a vector 3, a color, red, green, blue. For this one, you output red, green, blue, and alpha. Okay. So if you would pick this, it will run, for example, but we will stick to this one. For this one, it's for generating 2D sign distance functions. So you will have a float 2 as input and a float as output with the distance to your object for each pointing to this space. This is the same but in 3D. A sign distance function in 3D receives a vector 3, okay, the x, y, and z coordinates, and outputs the distance, also float. This is a variation that I will probably explain later, and this one is for making textures. It receives 3 coordinates, the vector 3, where you are in space, and for each one of them you say the color at that point in space. So it's vector 3 as input and a vector 3 as output. So each one of these types is basically a signature where you have a function in a type in input and a type in output. You can also define new ones if you want, downloading the source and adding new types which I have already made, but now we don't need to do it. It's very, very simple. So back to this example. The problem is that color has 4 attributes as a vector 4, and we are outputting a vector 3. So we can cut that by doing this x, y, z. Apply it, and now we don't see anything. Okay, here it is. It works. Nice. And you can change, of course, the colors. That's some very bad colors. Okay, like the Japanese flag. Here is the, so this is not a texture, okay? What we are making are shaders, so the output from here is a shader, so it doesn't have a resolution, right? By the way, we can also add some controls here. So for example, for the size we can add, let's try a different control. Oh, it's this one, radius. Exactly. So we can now just use this. So we have made a new node, okay? And you can now save this node. We could also add, for example, the position, but for now I think you understand how it works. So here you specify this code. This code will be inlined when the material maker generates the shader. But for more complex things, you will have to use also these steps. So, for example, we could also remove this from here, put here in the main code, and use this. So each instance of the code would have a specific name. So I will explain what I mean. So this is a vector 3, a like color, for example, equals to this. And we can't just put this here. Okay, we have to. I don't remember. I think it's 9. So let's check the documentation. The user manual. It's here defining a shader node. Okay. So here you can see the documentation and it explains. So the main code, this is a problem. The main code, you can't just use a normal variable. You have to use this name underscore UV. So let's continue our example. Okay, let's transform this into a variable. So all this code will run. If you have lots of code here, instead of doing just one line, you can put the code here. But you have to be careful because your variable must have that syntax. So it's a vector 3 name UV. Let's see if it's exactly. Oh, and the $sign before name UV, and then you do an underscore or something and put the variable name. So color out, for example. And now you can use. Okay, let's check this, and you can use this still works. And this way you can structure your code. And so let me see. Okay, another interesting thing now, we have this our custom node. You can also use Control D to duplicate the node. Okay, and we can now blend this, for example, and dragging. Let's see the output. Okay, it's between the one and the other. Let's change to colors. This is odd. No, I want it red again. More pretty. But we can also create a group using Control G. Okay, and now we are inside the group. So the group has parameters, and we can link parameters to this. For example, add a parameter and give it a name. We have to add an output, right, called in this case a color. Okay, link it here, and you press here to go to the parent, and now you have the graph. So, but you can't edit anything, right? So you have to make these variables as parameters. So you can have a very cool way of linking the parameter. So this is the size of the first circle. Let's call it size A, and let's create another for this other size, call it size B, and we can also use, for example, the color. Okay, color A, it will also be linked to this, and you have color B. Color B. Color B. Let's see, go back to parent. So this is the first, second. Oh, they are the same. No, the size is different. Oh, it wasn't linked for some reason. Okay, so now you have this and this, and you create a node that is composed of other nodes. So you can see this is very flexible. Okay, and we haven't still touched the inputs, right? So you can also have inputs and use that inputs here. Oh, a very cool thing, you can use time. There is a special variable called time. Let's use a sine function over time. So if I put just time is always increasing, so we have to do a sine function with time as input. So the sine function goes from -1 to 1, and we want this value to go around 0.1, so we multiply this by 0.1, and now it's between minus 0.1 and 0.1. Now add something like 0.2 or 0.5, for example, and yeah, you see now that the value is changing over time. So yeah, you could export now this to shader toy, and you already have a shader, an animated shader, and it will work. So another, let me see. Okay, for now I think it is. There is some. Not here, but here. So these tabs, I would need to explain more in detail exactly what they are for. So now we will start doing some 3D stuff. For that you will need my nodes. Well, not exactly. If you want, you can also use 3D stuff as is. So, but the visualization is this one. So this is a sine distance function of a sphere, right? And it shows this visualization. But if you want a different type of visualization, you need to load one of my nodes, or you can make your own Raymarching node. Okay, this is one of that. This making a Raymarcher node is something that you can do in the tool without. It's just GLSL code. Okay, I will show that to you. So why does Material Maker have these 3D sine distance functions? Well, because you can use these sine distance functions. For example, let's add here a box. The box is here, and we lose the boolean between the two. Okay. Okay, now we have this, and you could now use this as you can all. They have here. Material Maker has this node you could use. This has basically the weight of the 3D function. This is the normal, and this one I don't remember, but I don't use this. I made a different node, so this is the part that is new. You have to go here, load selection, and let's use my desktop. You have this, so if you unzip the file, you will have this file. So each one of these is a Material Maker selection, basically. For example, that node that we created previously, we could save the node by making one of these files here by going File, Save Selection. Okay. You have to be careful, because if the node was not modified, if the node was modified by you, the file will only save a reference to this standard library. Okay, but if you do Control W and edit something, it saves the code also. Okay. The same it happens when you save the material. So if you alter something in one of these nodes, when you save the material, your code will also be in the material, unless it's one of the official operations. Okay. So this new functionality adds the possibility to save your node, a custom node that you made, and load that. But you can also use copy paste. For example, even this node that is built in. Let me just modify something, and then I use Control C, and if I open, if you paste this to a test editor, you will. I think we have a comment. Something. Yeah, I have a comment here. Let me see if I can double click to write a comment. I have actually never used this. Yeah. So this is the code, and it is. You can, if you know, you can edit this, okay, outside, and if you paste, the node will appear. So you can, for example, just it's a JSON file. You can copy this JSON file from a normal text editor, and when you do Control V, a node will appear here. So it's very, very nice. Okay, let's delete this and load my node. Load selection. So that is why it's called selection, because you are saving a selection. It's not just a node, but a whole selection. It saves the nodes and the connections between them. So if, for example, if I do this and do file, save selection, it will save a JSON file with all the nodes and the connections and the code of the nodes that were modified. Okay. So I have 3 different Raymarching, but I would like to make more, and you can also make more. Let's start with this one. So this node is a custom node that I have made. I can show you here the code. It has some inputs, which are the sign distance functions and the 3D textures that I will explain later. The code, you can see here that we use that. Here we are not using main code, we are using just instance functions. Okay, the instance function needs to have a suffix or a prefix with $name. Okay, and I didn't use global functions here. So this little checkbox is very important, because if you check this, the input will be used as a function. So this is very important for, and actually I think it's a very rare functionality in node-based systems, because it's different when you receive a value. Nodes can receive values, that's normal, okay? Every node system has that. You can receive values from inputs, right? But here is different. You are actually calling a function. You're saying that, well, this is a function, and that is very useful. And that way you can use the inputs can be a function, like for example the sign distance function or the color that is a 3D texture, and that's it. So this particular node, right, only has 2 objects for simplification. the object A and the object B. The object A, oh, by the way, it already shows something because you can apply default values, so it's showing this. And you can change here, let's use the alt, you can change here the values, cameras, where you look at, camera distance, the specularity of the object, how much is, okay, 0, and in this case 1, okay, where is the sun? This is a very cool input that you can specify. You can have an input that will be converted into a color gradient that you can edit. So you can, for example, I use this for the sky, which is very handy, and you double click and you have more precision. Very, very cool. This is the ambient light, if you want more ambient occlusion or not, if you want shadow, but it's a very basic node, nothing very special. So let's substitute this by our sign distance function that we were building here. So now you have things start to get interesting, and you can now start to build your sign distance function. So let's start with boolean, right? We have a boolean here. No, at this point I don't think the visualization helps very much, so because the visualizations are made for textures, and here we are not using textures, so we would have to have a different type of visualizations, like something more like this. Okay, so this is a visualization from this node. By the way, this generates an image, and you can also transform the image. Let's see, for example, blur. Okay, so it bakes something like this into a, for example, this blur bakes this into this resolution. By the way, the resolution is fixed for X and Y. This is it's not a normal thing, but when you export it in shader toy, everything will be okay. So the blur function first is this node receive an image as input, so the green is images, and outputs another image. So let's continue. So you have also different types of unions. So one of the most used union is this small boolean. Yeah. It's very cool. You can do all sorts of things with this. You can, for example, add now a translation to the sphere. And a smooth boolean here. You can also animate this with time again. Too slow, let's increase the speed. And add you can continue to play with the shader. So this is using the default. So this node has two objects basically. One object is this one that we override, and the other object is the floor, right? So if, for example, we had, for example, a box, and we apply here, so the box probably isn't being shown. Oh, there it is, the box. Yeah, you can now use two objects if you want, but we will stick to this floor. Another thing that you also have is 3D textures. Okay, so let's use, for example, this pattern. It's purple. The purple are 3D textures. Okay. Yeah, now every point in you can use different combinations. This is a very cool node to make. Yeah. Multiplying. And you can, another very cool node is you can use colorize. Yeah, so to do here a modification of the colors based on this color gradient. Okay. Let's remove the time. We can also, for example, animate the camera using the same variable time. So it's seen. Let's make the camera spin around the object. So scene time, let's back away a little, and so we don't want to spin very fast, right? So time, now it's cosine. Yeah, probably it's 2. Let's back up, let's get further away, probably too far away. Let's use 4. Okay, translate. We will remove now this from now, don't need it. Let's just use the object. Okay. What you can, well, you have lots of different functions. For example, this one, so cool. So in Material Maker, the functions are periodic. So yeah, so they repeat because you want to make textures, so you want that property, right? But I used the code for that is not periodic. So let's load one of my nodes, which is text 3D. No, it's generator Niket. It was from user Niket from shader toy. Let's use, for example, simplex. On these simplex nodes with octaves. Yeah, it generates this moon. Yeah. Can have scale. Let's use the Alt key to transform the values. We have scale here. Let's put this pixel at 1. The number of iterations. Persistence. Brightness. Contrast. And its clamp if it was false. And so values can be over 1, but it's not very good to do that unless you do some special things. Let's go back to the pattern. Yeah, so let's try something here. Let's multiply, use sine here. Let's enlarge here the preview. You can zoom. I don't think there is a scale for scale. Let me see. Oh. Scale. No, but I made one. Again, these nodes are very simple to make. If you, for example, this scale node, if you see the code, it's just this. It's nothing very special. So it's very easy to do nodes. I'm doing this seminar because I want people to share nodes. I would like here to have an integrated community using Material Maker where you could share your nodes and people would use other people's nodes, because there are very, very smart people out there that I'm sure that could make great nodes, and designers could use that nodes like I explained it in the beginning of this seminar. So okay, this scales the node, scales the pattern. I'm now using, here is the Alt key. Can use the Alt and the Control key to do this. Now I will use one of my modifiers to the sign distance function, so you can have modifiers in the sign distance function. One of the modifiers that I like to use is distort by normal, so we will modify the weight by the normal. Okay, so this node receives what? Receives the sign distance function. Okay, so now we don't. This is how much we are displaying, and receive a pattern. So this can be this pattern, and if you do this, yeah, you are modifying. I think it's very cool. But if let's change here, for example, the colors. We are now modifying the. This is when it starts to look very nice. Oh, see what's happened. So sign distance, when some modifications are not make the sign distance function just an approximation. And when that happens, you have to correct. So when I make nodes that need correction, I add here some manual correction. By the way, also the shadows and the occlusion mapping, they're also fake. They are not true shadows, and so okay. And shadows are also, they use an approximation based on sign distance functions, but because sign distance functions now are not correct, we have to sometimes remove the occlusion, so if you after the correction, okay, but you don't need this amount of. So if you can just lower the correction, it's best always when it's 0, okay, because if you add here a value, the shader will become slower. We can also have, for example, another sphere, duplicate this sphere and use a join function. Here's smooth boolean, and now translate. Oh, it's not correct, it's this one. Okay, I would like more this if it was not nodes, but it was like Werkzeug with like a stack based approach. I don't want this, I want smooth boolean. Yeah. Okay, translated. Yeah. Yeah, you can also do a subtraction. And you can make some very cool procedural elements here. For example, if you change here for something like this, look what happened. We're now modifying and creating a completely different object, and you can still, all this can also be animated, of course. Let's see more things. Okay, for example, the object that you see in the presentation, I can now do that. By the way, this is deformation by normal before I made that object. Let's use another kind of deformation, which is deformation not by normal, but it's also by normal, but it doesn't only affect weight. Is this one we just replace. But by the way, you can have several of these nodes. So, for example, I could have another node here showing the two. Let's make it. Okay, here and here, and now you have two exactly nodes. But now we will use this one instead of the other one, just to compare the two. This also needs some correction. Yeah. So this can generate distortions that are not connected to the structure itself. It's nice. This also is always connected, right, because it only affects weight. Yeah. Let's load examples that I have made previously. So similar to the one we have made before. I made this chair exactly the same, but with different texture 3D functions, right? So you have this, then it scales. I use brightness and contrast to change this,
then it uses the original noise function, it blends the two, and then this output goes to the distortion and again do a brightness and contrast, colorizes, brightness and contrast, and then the same rotation is applied to the texture and to the object now. So you can, instead of the camera being rotated, is the object that is being rotated. I think it's nice. You can, okay, this is changing the colors, of course, but here you can change. So this is the distortion that it's not based on the weight, it's not based on the weight, but it's based on the normal. So the distortion is not just plus a number, it uses the normal at that point, okay, to distort. This is a sphere and a box. Can change here the blending between the two, can change the translation. This is a cool thing. And box size. Wait for. Can do some really cool procedural things this way. There was a node that doesn't exist yet because you can't make it with GLSL. With that, I think was relatively easy to do in Godot. By the way, sorry about my English, sometimes I screw up in saying some names. Well, English is not my native language, so sorry. Ignore, please. So in Godot, I think it was simple to do because the node would break the object into this object into a real object with polygons. It is relatively straightforward to do because you can assign the colors to the vertex and use marching cubes, for example, an algorithm that transforms this kind of things that are not made of polygons into something with polygons. Of course, that the resolution, for example, for this kind of model would have to be very high. But yeah, I think it was cool. You could export this object and use it in another program. You could print it. It would be very, very nice. But it's something that you can't do directly in the program. It's a node that has to be made inside Godot. So let's continue. Let me see other examples that I have here. See this one. File. Oh, this one is also similar to what we have already done. Yeah, it's the same thing with different textures. Okay. Here, translate. Very nice. So only the texture changes, so we can play with this a bit. So for example, we can remove this noise, okay, it uses the default, and add, let's set, for example, another noise, for example, let's see, cat, simplex one with octaves. What have we done here? Okay, slightly different. Again, starts more. This is being distorted by normal. Let's change this and make a distortion instead of by normal. By normal. Wait by normal. Start by normal. What is this? Let me see. Remember. Is this the one? Whoa, oh, I forgot this. Yeah. No, it's different now, you see. Now the object can... I have to apply some correction. Yeah, and remove probably the end of the occlusion. Also the shadows are not correct because shadows is... that's some slight... some correction. So the correction, the node uses the distortion level in conjunction with correction to try to figure out the necessary amount of correction in distance field. Okay. Of course we can also change this. This is subtraction. Put a larger sphere, small sphere that is subtracting. Okay. Video union. Whoa, this was a very big rock. Block. Nice. Yeah. So let me see another one. This is kind of old, but yeah. Right. Also, it's just kind of a donut. This use, I haven't talked about this, because the 2D distance functions, let me show that to you. The 2D distance function, you can use 2D distance function to make other objects, doing, for example, a revolution around the 2D distance function. Okay, now it's rotating. Let's remove this. Okay, so for example, we have a box here. Okay, this box. Oh, I use this. I don't know why. And we scale, rotate this, and then we apply a revolution. So we this node receives a 2D and then applies a revolution around the center. Okay, let me show what I mean by this. So this is the object that is rotating around this axis. For example, this node only revolves around this axis, but we could change the node to revolve around other axes. Let me, for example, change that. Show you. So yeah, the code is very simple, as you can see. We do X, Y. Let's use Z and Y. Let's just change these coordinates. By the way, you could, for example, put all this text in a variable, and one of the inputs is an enum, and the enum would be the several options that you could then use here. Okay, I can show you that after. Let's see. Yeah, this is node. This is being rotated, so this object is being rotated like a vase, okay, something like that around. If you move here the center of the object of the 2D function, this also applies. This was probably just to get, don't need this actually. Oh, okay. Centered. Yeah. It's just to make it rounder, probably. Okay. So, okay. So I wanted to show also different types of Raymarching. I have this one that uses a matcap image. Matcaps are those images. I can show you what do I mean by this. Basically, it's like taking an image of a sphere with reflection. Okay, you apply it here, and if you set, for example, direct, it will show the image. So in this is a sphere, so it's not very interesting. But if you do, for example, torus. I deleted. Yeah, you have big reflection. You can also do mix. Try to mix, blend between the two, and do some nice things. Depends on the image, right? Let me see if I have another image here. There's an interesting one. For example, this one. Okay. This is a node-based program, so you can also modify this image, like for example, brightness, contrast. So you can now just the brightness, increase it. You are now dealing with an image. Another note, it uses panorama images, HDR panoramic images, and also have reflections. I used some reflections in this one. Let's load here an HDR. HDR are large. This one has 24 megabytes or something like that. Yeah, so you can see now some shiny reflections here. Yeah. Too shiny probably. Okay. Now you can also apply a texture pattern. Here, yeah. So that image that I showed in the presentation was made with this node. We can just remove it, use the original sphere, but the difference is that this has two objects. So by the way, this node, the default object is not a plane, something different. So it's this, like a ball, a sphere splitted. Okay. Let's just concentrate this. So yeah, this doesn't have yet the controls for camera, so it's difficult to adjust the camera and also to position the objects. But okay. Again, this is made to make textures, not Raymarching. So yeah, we are just abusing here the potential of Material Maker. But so the difference is that now we will use we'll try to remove the second object. We could change the code, but we will just create a very small sphere in order to. This is a sphere. Now it's inside. It doesn't exist. Okay, now we will only have the default object. And this is a sphere. We will now load a plane. Wait, I don't think I have a plane here. We see generator. Yeah. SDF. No, I haven't made one plane. But you can also use the normal box for it. But it has some problems, so we will create one. It's a nice exercise. Custom shader. And we will just like to make a plane. No parameters. Just one output. Sign dissatisfaction 3D, where it's UV dot epsilon. See if it works. I think it works, but yeah. Now you have a plane, a red plane. With no parameters, just this code. We could make it smaller by intersecting it with a sphere. So this is sign distance functions math. Again, the $UV. So this is the formula for a sphere. Now you have a small sphere. You can make this a parameter. Call it size. Let's call it size. Float, min, max. Let's just the steps here. I like to have precision. Yeah, so we cannot change the size of this. So this is a plane intersected with a sphere directly in the code. So let's make it move in so we don't see. And apply in this one. Let's apply to this the pattern. Have this pattern, maybe with 3 or something. combine this new object with a sphere. Okay, this is a sphere. No, not this sphere. This is a 2D image of a sphere. This sphere. You can just click on the output, drag, release, and you will see the operators that work on this output. In this case, is the smooth boolean that I want. Okay. So it's now. Yeah. We can now doing nice. Cool. Translate sphere. Yeah. Let's put some rotation on the camera. Could also animate this if you wanted. So I also added, in the example I also added some distortion. So for the distortion we need, let's load the NiCat simplex noise. Where is it? Here. Okay. And my distortion would be the distort. This one. Way too much. Yeah. There are many shiny objects in the sky. Maybe we can replace it with a different image. Let me see. Okay, this one. I'm loading a different HDR image. Okay. So, yeah, this is now the object has a distortion. By the way, we would have to. So the sun is at some point. I don't know where is the sun here in this image. It's, let me see, where is the sun here? See the sun. Oh, here is the sun. So, but now I can see the object. So the sun is there, right? So we have to. We can align the specular. So the specular here is at 0, but we can align. Let's just remove this distortion. Translatable here. The reflection, remove the reflection, and this sun and this fake sun should be aligned. So we have to move this sun so we can have a more correct. It's never correct, but a better fake. Okay, let's have this to have an exact. Why do I have still speaker? I don't know. reflection. Yeah. Still need this. Yeah. More or less is this. Yeah. So now the shadow is more aligned with the image. We don't need this anymore. 0. Let's continue. So you have distortion. And use. And yeah. That was the demo. Let's apply a sine function with time. Yeah. Probably too fast. Somewhere. Yeah, it's now appearing. Probably too slow. Yeah, this is nice. Oh, okay, it's correct. Yes. So this was the effect on presentation. I also want to show you a nice feature called custom joins, custom unions, better. So that we'll use 2D SDFs, like for example. So how does it work? Or what do you want to do? So this is a union, normal union. Okay, it's one object or the other. This is another one that makes a smooth transition between one and the other. But we can actually visualize this. Okay, let me show you some custom nodes. Let's use an input, no, to the input, okay, and duplicate load selection, use this visualization from IQ, sorry. Can use this, yeah, duplicate, and use the Y. So this is what it's doing, right? So the intersection between two objects maps into a 2D distance function. Okay, can be a little complex, but if you don't understand it now, one day you will understand it, I hope. So this represents one object and this represents the other object. So in a union you have both objects. In subtraction, you subtract one from the other. In an intersection, we only have an intersection in this part from this object and this object. A smooth Boolean, this is happening, right? If you do this, it's exactly like this union, right? But if you do this, the distance between the two fields will become this. Okay? So we can use these to join objects, of course, right? So if we can, if we add here a sphere and let's use a cube. It's more cube or box. It's called a box. Box and another box. duplicate. Control D duplicates the element. We have to translate this box. Translate. A bit and join the two. So we will now join these two objects. We will join these two objects with this join, but in a different way, with a custom union. Probably union is the best word, not join. So SDF custom union. Nope, it's not this one. Load selection custom union. Oops, there was a problem here. That's the object, it's not correct. Let me correct this. Let's load one of the examples. This is the one that I'm going just to copy the object here. I will correct it after. So the zip file, it's wrong, I have to change it. Okay. By the way, now you don't have access to the zip file, but I will, after this seminar, I will tweet the zip file. Okay, and for some time from now it will be available on my website. So these two objects. Can't see anything. I don't know exactly why. So this was what we were going to do. Yeah. So this uses the normal smooth boolean, but we want to make a custom one. But it isn't working. Let me see the code. Probably the code isn't correct. It's this. I remember. It was here, I bet. Okay, now it should work. Yeah. So it's exactly the same. We are doing exactly the same thing. We are visualizing here the union that we are creating. This union is already made, so but we can make special unions. Okay, so for example, instead of this, let me show what I mean. Let's use a normal boolean to use these two and visualize it. So this is the standard union, right? But we can, for example, everything that you draw here will appear on the intersections. Let me see what I mean by this. For example, if you draw a sphere, not a sphere, a 2D distance function of a circle. So it's called circle. No, it's not circle with width. I have to search here. It's circle. We can do another union between these two objects. Okay, and now you have an object here. Let's see what happens. Okay, way too large object, but okay. See, this object have appeared because I made. It appears because of the union between the two objects. It's a very powerful concept. It's really, really nice. Nice. So let's translate. I hope there is a translate. Yeah. there is a translate for it. Let's change it to be more close to the. Yeah, so you can see what I'm talking about. So if we change the intersections on every intersection, it will create this object in between. You can make different shapes, you can make stairs, you can make whatever you want. Okay, it's very, very nice. Let's. We haven't even used a HDR image. Let's use sunflowers for it. Better. So the box. Oops. Okay. Whoa. I don't know exactly what I'm doing here, but it's nice. Of course, you can after it you can continue to add, for example, deformation or for example, that probably is a good time to show you that you can add, so you can deform space. Okay, it's a very a thing that many people do in this. Can, for example, use symmetry and axis symmetry. Not this symmetry, because this is a texture symmetry. We will use SDF axis symmetry. Okay. And now the object is symmetrical in X, Y, and Z. Let me show what I mean by that. See? Okay. We can apply again another symmetry and so forth. But I think you get the point. Again, this is very, very simple code, nothing very magical here. Actually, the code it's here on the enum values or the possibilities. It will replace this code with this variable mode. When you apply here, mode will be with the values that we use here. For changing symmetries, for example, if it was just X symmetry, Y, X, for example, this one, let me, yeah, can also, after this, we can scale, no, yeah, we have scale. Now we will try to make some fractals. First load the render. Load an HDR image. Yeah. Let's make a box. So not this box, this box, that was a 2D distance function box, and now we will apply some transformations. We will first translate the box, Okay. Then we will rotate the box. And then we will apply symmetry. Okay. Because we have this symmetry, the space is being we are just drawing a box that says here send over time animate. Sign. Yep. Maybe a little more far away. If space is being folded, is being copied. So when you basically when you draw a box, you draw a box at the center, right? Then you translate the center, you rotate the center, and then you mirror space. You mirror the space, so the box will be drawn everywhere. Because in these 8 places, you will have the same coordinates after this symmetry. But we can continue to apply these transformations again. Right, so you can copy, duplicate, Control D, go here, here, and yeah, we have more cubes. Right. Let's make a smaller box. You can do it again and again. So this makes a fractal. One kind of fractal that you can make. So instead of doing this over and over and over, we can use a custom node. This node, this graph can be an input from another node. So this is where, again, Material Maker is extremely powerful in my opinion. Let's use the generic fractal. Yeah. So the transformations can't be these ones. Have to be. We are transforming. So this is a texture 3D, but we are not using the texture 3D for texture. We are using the texture 3D for transformations. We will see. We'll see what I mean by this. Because basically that's a float tree. So we need a transformation. For that we need to load this input. Yeah. So now there is no transformation, but we can start to apply here the transformation. So we can now translate. We don't have translate in text 3D. Translate. So again, so you see what happened. Yeah. It's applying this transformation 4 times. Okay, let's go 3, 4 times this transformation. It's translating this object. After this, you can also rotate, for example. Yeah. Six times. Oh man, you would want, and we can also apply symmetry here. Axis symmetry. Okay. So now just this one. Yeah. You're starting to make nice fractal. See? So the base object in this case is the box, but you can use a different one. For example, a sphere or a combination of objects. So the possibilities are endless. See? Sphere. Another very nice thing is that the way you join these objects can be so this is fold and this is mean. Well, basically in the fold you are just you apply symmetry to space, and here we are actually using multiple spaces and combining them. And you can also use custom. Okay, and in custom you can use custom 2D unions. So for a custom 2D union, let's load duplicate this, the Y, can also use 2D. So the 2D and 3D unions are exactly the same code. It's union, no, I don't remember the name. Smooth boolean. Yeah. In this case, it was this one, but you could use a custom one, right? It's not exactly perfect because let's use it again. The box, yeah, it has this nice join between some boxes. You can change all this, rotate. Make some cool objects. Can play with ambient lighting, more reflection. Way too much reflection. Yikes. Okay. Nice. So, I was using the fractal. And well, we could also use this to make a city using fractals. I think I can leave that to you because this presentation is getting too long. thank you for joining me. Sorry about the noise, the background noise, because I think this microphone it's not very good. Sorry, but well, you have my Twitter. Is Paulo Falcão, and if you like this, follow me at Twitter and talk with me. I can also help you do more stuff with Material Maker. Thanks.
Hey, Paulo, are you there? I can hear myself on the stream at least, so that's a start. You need to unmute yourself on Hangouts video call.
Hi. Yes.
Hello.
Peraí,
Thank you for the presentation, Paulo.
Peraí. Deixa eu ver. Eu have
The other headphones.
I'm here.
You're here, but the screen is black,
Yeah,
so you're
wait,
not
wait,
showing
wait,
us.
wait. Yes. Are you hearing me? I have to...
I'm hearing you, yeah.
No?
I am hearing you,
Hang out.
and I'm seeing myself, so I guess that works.
I can't listen to you. I don't know why. Oh, okay, I know.
Hello, hello, test, test.
Okay.
Can you hear me now?
Yes, yes.
Okay, good. Thank you so much for that presentation.
Uh,
Sorry everyone for the technical details,
Yeah.
microphone and stuff. If
Yeah.
everyone pitches in, we can buy Paulo a decent microphone. Was that the headset that you used? Because you sound all right now.
Yes, I don't know why. And I used two different. I have this one and another one, and on both that happened.
Both of them sucked.
Yeah,
Yeah.
I don't understand. Now you can hear me perfectly, right?
Yeah. Without noise, which is the most important part. I like noise, don't get me wrong. I love noise. I mean, but for a presentation, it would be better without it.
Yes, yes.
Anyways, it is what it is. We still understood, so thank you so much for that. A few questions that I had to ask. Well, we had a long chat alongside, but for people who are only watching the video of this, I'm gonna re-ask some of the most basic questions. So one of the first questions that I was asking earlier on, can you make sound with this? And we had the maker on the chat saying that yes, he did like a test thing for April's Fool that you sort of could make sound, but it's still not really very usable. I think that's really powerful. Do you wanna do any comment on that, Paulo?
Yes, of course. You can now you can't do sound, but the potential of that program, at least in my view, is that that functionality where you can use nodes that have inputs that have other nodes, so you can do lots of complex stuff with audio also. There is a problem with audio because with audio to have a fast response you need to have you can run shaders to generate sound, but in real time
Not real time, yeah. Shader Toy has the same thing. It like pre-renders the whole buffer, and then you get to listen to the whole thing. You don't see it real time.
Yeah, but
you have to throw it to the audio buffer.
Yeah, because you have a problem because in audio you have 44,000 like frames per second, right?
Mm-hmm.
So yeah, and sometimes you want to use the last frame to do something on the frame, like being the so you can
like reverb or something.
Yeah, you can paralyze that. So for example, the shaders on Shader Toy can't use that. They can't use they can't do reverb, for example, because of that.
Mm-hmm.
Because everything is rendered simultaneously.
Yeah, that's a limitation of pixel shaders themselves. I heard with compute shaders you can do that.
Yes, exactly.
But we would need to have some sort of framework that would like take the shaders and rerun them as compute shaders instead of pixel shaders. That would be a bit of a mess.
Yeah, but you could if you could use the language and compile the language into the CPU, for example, instead of running on the graphic card, and it could also run. Okay, but it's completely different. It's not what you are, but in the concept way, yeah, it's possible.
Okay, another question that I was asking was, how do you handle material IDs? Like you have a cube that is white and you have a ball that is red. How do you distinguish them after you do like all the reflections and symmetry and stuff?
Implemented that where you could add, for example, when you have a sign distance function, you have the output of a function is the distance, right? Is a float. If you want to add the ID, now you have a vector 2, like two floats, right? So how that works, you have to use special nodes where you can assign that float. You convert one float to a vector 2, where the first one has the distance and the second one has the ID, but it's not very clean. I personally never use that. I don't think it's very intuitive. For example, I didn't have time to implement, but I was going to implement something that textures could be blended. Okay, you can have two objects, one with one textures and another with another textures, and the textures were blended between the two. Okay, but that also has a problem, because when you are Raymarching, you have to also evaluate the color, so it's more expensive, but makes pretty stuff. You can make.
How do you handle what is usually considered post-processing, like global stuff? You usually calculate like for fog and stuff like that. You usually calculate or glow. You calculate along the ray. How does the node-based interface handle that?
You calculate yes. So for example, if you are doing a real post-processing, you bake the render into an image, and that you can already do in Material Maker. So Material Maker, I was only focusing in shaders, but you can also use shaders to make transformations on images. So you can do a render, the render does your image, and then you blur the image and combine multiple images to do.
How do you export that? Like, how is the?
No, that can't be exported. The export is just for the single function, so for a type of output, so not the whole graph. Okay.
Okay.
Yeah, it's true. You can't export that. But
interesting.
Probably, normally the pipelines are relatively simple. Like you have your render and you do a blur, and then you do a color fixing or something like that. So it's just 2 or 3 steps. You can probably implement that yourself manually, and use the shaders generator.
So what kind of nodes would you like to implement next? Like, what sort of thing do you really feel like it's missing that you would really like to see?
The things that I would like to implement are things that I can't do now, because they can't be done with the GLSL. Okay, so one of the things that I would like, so the things that one thing that has nothing to do with shading and shaders is a community. So like there you could just in the program do share node, and other people would see your node and would vote in your node, and people would start using your node, and you would publish a bit like Shader Toy, right? And for example, you could prefix the nodes could be prefixed with your name, and if one node was not good, you downvoted it, something like that. I think that would make the program very, very popular, I think.
You would also start having a lot of nodes that are just like nonsense or not quality, so it needs to have like a certain trade-off of of quality control.
Of course.
I like the approach of Cables GL. We had them on a seminar a couple days back, and they also have a node-based interface, as you know. And what they do is, like, if a certain user has done a specific node, they don't make it public, or only the user has access to their nodes. But if they talk with the developers, they can include it on the next version release, which sort of makes sense.
Yeah, that's exactly how Material Maker also. If you talk with Rodzilla and have a nice node, he will include that.
He will include it on the next version.
I had, for example, now I have 10 or more nodes that I use in this presentation. I will share the nodes with him, and if he wants, he can also put some of the nodes. Because, for example, a Raymarching node is something that I think changes, because it's never very correct. Like, you do some approximations and do some, because you can have one Raymarching node that do a render, and it could include that in the program, but as a start and use that, and for most people it's good enough. But in my point of view, there is always something to add there, something to tweak, something to for example, my nodes only have 2 objects. I don't use that functionality of the IDs, okay, because I think makes things much more complex. So if I want a 3rd object, I had to code one with 3 objects. So
yeah.
So
how easy is it to change that nodes that already exist? Can you, like, edit the code that they, like, if I'm using the tool with your node, can I just change the node easily and start using my own version?
Of course, yes. I said that multiple times in the seminar. You can just press Ctrl W and you now start editing the node.
Because I saw you could change, like, the code and the parameters, but you can also change the input and output, so you can pretty much define everything.
You can change everything. And when you save, it's saved not a reference to the original version of the code, but it's saved your code
as your own version.
Yeah.
Okay,
in your
that's really
file.
cool.
And by the way, another thing that I think it was very cool was something like baking a 3D object, okay, and that was very nice to do. For example, objects for 3D printing or exporting to another engine, the object in polygons, and that is something that you can't also do in GLSL, but it's possible to do using the source. So everything is open source. So the program is open source. It's not. I always change it.
I say Godot, but if you say it's Guido, I'll believe you.
Well,
I never had a pronunciation war with anyone about Godot, so I don't know. You might be right.
We read, and well, so everything is open source. So you can always look at the code and implement your fork and implement your own version, and probably in the future it will be merged, I guess. So yes.
Black Pawn was asking on the chat, has the tool been used on any demo scene productions? Do you know of any, Paul?
Not mine. No, I don't.
No, not
so.
yours. You did something at Inércia last year. Was that using Material Maker?
No.
It was
At
before,
last
you
year,
know.
Yeah, I only knew Material Maker early this year, about January or something like that. But I was, like I said in the beginning of the talk, I was for a very long time interested in doing this kind of node-based program that you could use nodes to make shaders. Okay.
So you finally found the tool that was matching your idea.
I'm too lazy, and I was looking Google for someone else to do it. So I said, well, if I have this idea, probably someone will have the same idea and code something like this before me.
Okay. I can't think of any other questions. Don't know if there's anything in the chat. If anyone has any final questions, now's the right time to answer them. Paul, do you have anything else to add? Any recommendations or maybe recommendations for people who are starting to do shader coding stuff? I don't know.
Yes, you can if you just like to play with the tool and do 3D stuff and you don't know nothing about Raymarching, I think it's a very nice tool to experiment. I don't know sincerely many tools where you can just use 2 or 3 nodes and suddenly a chair with spikes appear and something like that.
How exportable was that chair? Like if you wanted to put that on Shader Toy, you would have to upload the textures there as well?
There were no textures there. It's copy paste. You can.
Oh, it was a noise generator. Yeah. Okay.
Yes. Mm-hmm.
Okay, so that's even better. You can just use it straight off on your code.
You can.
And I guess you can also use the texture generator part of Material Maker to also create your textures. I was talking in the chat earlier that like most people who do live coding on or even 4 kilobyte intros on the demo scene using just Raymarcher on Shader usually don't do very weird textures. They stick with something that is very simple. If they use textures at all, sometimes it's just weird colors and stuff like that. So it will be interesting to see like generate the textures and then apply them to something interesting.
That's for people that already know how to make Raymarchings, like for example, like I do, using a node-based system where you can tweak some parameters, I think is very useful, because when you are programming, you have to, if you can have something in your mind and you go there and change 0.1 to 0.2 and try to imagine, but it's much faster to go there with the mouse and
just scrub
and try some random things, and suddenly you have some great stuff on the screen.
We were also talking about a way to sync the stuff. There isn't like a very good way to do it right now, is there? Like if you want to do like sync, like animation timeline sort of things.
Yes, of course. But it would be possible to create a timeline, and that timeline would be exported into a GLSL function. Okay, a bit like the gradient. The gradient, you have a gradient, for example, there, and that gradient in the program, in the function, in the shader, is transforming to a function with fixed values. Okay. It could become, if you have a very large timeline with very points, it could become complex, but I think it's possible.
It will be interesting to see an example of that. So yeah.
But it's just an idea. I haven't seen no one. I don't know if people do that, but it's possible.
Okay, well, I think I'm gonna wrap things up. Thank you so much, Paulo, for your seminar. That was very interesting. Thank you everybody who watched on the chat and was talking. It was a very lively chat today, so that was fun. So yeah, see you everybody tomorrow. Let me check what's on the schedule for tomorrow, actually. Because we are doing something every single day at Inércia. And a reminder that the submission system is open, so if you have entries for Inércia, you can already submit them. Just email us for a voting key and then go to party.woohoo.scene.org. There's a link on inertia.pt website, and submit your entries before it's too late. Yeah, tomorrow we have another seminar. Have to confirm with Frazão if everything is ready, or if you will be rendering the video until the very last minute. But yeah, tomorrow we should have a seminar on the bonsai tool, which is a very interesting tool for doing some interactive stuff and also data analysis. Very versatile tool. People have been using it a lot as scientific research materials for doing research stuff as well, and you can use it for graphics and visuals and audio. So very interesting stuff. Hope you guys show up. And yeah, that's it for today's stream. I'll let Paulo try to figure out where to click the button to stop the stream. And bye everyone. See you tomorrow.